On this worksheet, we're going to practice naming aldehydes and ketone molecules. And in this situation, we're not going to be coming up with the names. We're just going to be matching the names that are provided to the structures, the molecules that are down here on the bottom. Before we jump into that, I just want to talk a little bit about how we're going to go about naming these molecules. For the aldehydes and the ketones, both of these molecules contain a carbon-oxygen double bond functional group. So when we're locating the longest carbon chain needs to contain the carbon-oxygen double bond. We're going to start numbering our carbon chain. We'll number it from the end that is closest to the carbon-oxygen double bond. And then all of the other branches or substituents on the molecule, we'll just name them the same way that we would normally name them. So for an aldehyde is one that has a carbon-oxygen double bond and there is at least one hydrogen attached. An aldehyde molecule is going to get the suffix al to represent aldehyde. When we name an aldehyde, we drop the final E off the molecule's name and we replace that with an al to indicate aldehyde. A ketone is a carbon-oxygen double bond that has no hydrogens. So no hydrogen out here, no hydrogen out here. Typically, these are just carbon atoms right there. And when we're naming a ketone, we drop the E off the ending of the molecule's name and we replace that with -one for ketone. And just to clarify the aldehyde, because it is a little bit confusing, the other side of the carbon-oxygen double bond over here, this usually is a carbon atom, but it could also be another hydrogen. That would be allowed as well. So let's take a look at these names and these molecules and let's try to match them up. And the first one that we're looking at here down here on the bottom, this is a ketone. I know it's a ketone because there's carbons on either side. So when we're looking for the correct name, we're going to look for one that ends in -one. So it could be this molecule or this one or this one or this one. These are all ketones, so it's not these guys right here. So we've got it narrowed down to 4 choices. This is a 3-carbon chain that we want to number on the end closest to the carbon-oxygen double bond, left to right or right to left. It's exactly the same distance. And there are no branches or substituents on this at all. The name that matches best is 2-propanone. I'm just going to put a little, write the molecule's name down here, 2-propanone. Prop because it's a 3-carbon chain. I wrote propane. 2-propanone. Prop because it's a 3-carbon chain. One because it has a carbon-oxygen double bond. And 2 is the location of that carbon-oxygen double bond. It's on carbon number 2. Here's our next one. This is an example of an aldehyde. It's got that hydrogen attached to the carbon-oxygen double bond. These are the 2 choices that we have for aldehyde molecules. For this molecule, we want a number on the end closest to the carbon-oxygen double bond, which is the right side. No branches at all, so this molecule is going to be the butanol. It gets its name 1-butanol because it's a 4-carbon chain. We're giving it the al ending because it's an aldehyde. The carbon-oxygen double bond is on carbon number 1. Our next example is another ketone. So our ketones, what we have left are these guys right here. If we're just matching the names, the molecule that we're looking at has a bromine on it, and there's only one molecule's name that has bromine in the name. So keeping things really simple, 3-bromo, 2-pentanone, which again I'm picking just because it's the only name that has bromo in it. 3-bromo, 2-pentanone. Let's take a look at where this name comes from. We want to number our carbon chain on the end closest to the carbon-oxygen double bond. So that's a 5-carbon chain, so it's a pentan, gets the ending -one because it's a ketone. This 2 is telling us that the carbon-oxygen double bond is on carbon number 2. And our branch is on carbon number 3, and it is a bromo. Next molecule that we have here is another ketone. What do we have left for ketones? We have these 2. Ketone E, cyclopentanone, that cyclo means that it's a ring, and that's definitely not what we're looking at. So this molecule must be 3-methyl-2-hexanone. Let's see where that name comes from. 3-methyl-2-hexanone. So when we number our carbon chain, we want to start at the end closest to the carbon-oxygen double bond. And then don't forget, you've got to be careful, find the longest carbon chain. Don't just automatically go from left to right. You need to find the longest set of carbon atoms. So this is a 6-carbon chain, which makes it a hexane because it's a ketone. The carbon-oxygen double bond is on carbon number 2, so that's why it's called 2-hexanone. And then our branch is on carbon number 3, and it is a methyl. The next one here is there's our cyclic ketone. That is cyclopentanone. And let's take a look at where that name comes from. Cyclopentanone. So remember, when we have a cyclic, we get to choose which is carbon number 1. We're going to put carbon number 1 in the best position, the carbon that holds the carbon-oxygen double bond. When there is only exactly one feature to a cyclic molecule, then you do not say the location. You do not say 1. So in this case, we're not going to say 1-cyclopentanone. We're just saying cyclopentanone. We only have one molecule left, the last name that's on our list, 3-methyl-1-butanol. So let's see where that name comes from. 3-methyl-1-butanol. We want to number our carbon chain, starting at the end closest to the carbon-oxygen double bond. It's a 4-carbon chain, which makes it a butanal because it is an aldehyde. The 1 is saying the location of the aldehyde, location of the carbon-oxygen double bond, and then also our branch is on carbon number 3, and it's named methyl.